yourself.
Hello, I'm Bruce Momjian. I got involved with Postgres in 1996 because I was bored with my job and I was curious how a database works inside. And I'm currently writing a partitioning talk, which I'm kind of excited about. It'll be my 60th talk, I think. And I have a lot of travel coming up.
Okay, I guess it's my turn. Hi, I'm Magnus Hagander. Um, I think I got started a couple of years later than Bruce, but I thought you started earlier than 96. Wow, I think I got started in like 98 or something like that. And in my case, I actually needed a database and I couldn't pay for it. So, there you go. It's a good place to start. And then I got involved in mostly, I started out by just reading and following along with the Postgres mailing list and realized there was so much to learn and somehow got stuck in there. And keep on learning by reading those lists every day. You can still learn no matter how long you keep going. So I don't know, right now I don't think I'm working on anything in particular on Postgres, the engine. I'm also part of organizing a bunch of days like this, conference days over in Europe, and they're all taking place in March and the beginning of April, so there's a lot of time going into that for me right now. And also like the infrastructure and stuff behind the project that hopefully nobody sees because you would only see it if it fails. So hopefully you won't have to see that part. And then we're ramping up the work towards the next release of Postgres coming up soon. So there's going to be a lot of time on that for me as well. Okay, Robert, you're up.
Howdy, Robert Treat. Got started using Postgres sometime in the last century. I don't know. I think it was 98 or something also, but whatever, back then. I was doing web development, and my boss said, use Postgres, and he told me how to compile it, so I did, and it's pretty much worked ever since then. Um, so yeah, top-down decision. I really had no choice, to be honest. And so I'm still here using it. Yeah, I guess that's it.
Thank you. So my name is Devrim Gunduz. I'm responsible for the RPMs in the Postgres RPM, Postgres Community repo. I started using Postgres in 1998. Actually, I was looking for a database, and I used MySQL for a good reason. And hold on, and then it didn't work. Like I spent 2 days to make it work, and then switched to another database called Postgres, something which is hard to pronounce anyway. But I think Postgres, right? And then I realized and I learned that the MySQL package in Red Hat in 1998 was broken. So if I ran an up-to-date back then, I might be talking in the MySQL room right now. So joined the community, started did a few things like cleaned Postgres, but mainly nowadays responsible for RPMs, and plus I'm making sure that Magnus doesn't break the community website. So, hi Magnus.
Hi, my name's Mark Wong. Once upon a time, I did a lot of database benchmarking, and now I help out, run some events and other community things. I first got into Postgres back in 2003 at a place called the Open Source Development Labs, where we were trying to see if open source software could run database benchmarks, and found my way with the Postgres community, giving me a hand.
Thank you. So I learned today, actually I learned a lot from now that people started with Postgres because of boredom, not being able to afford other databases, not being able to work with other databases. So there's definitely a fascinating backgrounds here. And actually top-down decision too. We're seeing that more and more today as well. So let's open up the floor. Like, what do you want to learn about Postgres? Yeah, hi.
So I'm obviously a student at a UC university, and I went to the Wikipedia page several times. And I'm like, why is the regents of the UC system involved in this? So could someone give a little bit of like the history and how and why the UC system is still involved? Like it says regents, which is really weird because since they're like the owners of the UC system and have nothing to do with the education system itself. And I was expecting like, oh, maybe a comp sci department, like if the UC system still maintains it. But it's like the whole administration is involved in this. So could you explain a little bit about that?
Thank you. Excellent question. Wants to handle it? I think everyone's looking at you, Bruce. I think you're the custodian of this history.
So originally, Ingress was developed at UC Berkeley in the 70s, and in 1986, Michael Stonebreaker received a ARPA, the Department of Defense grant to develop the next generation of relational system. He worked on that up until about 92. Then some other individuals took it over in 94, 95. And we became a community project in 1996. The reason the copyright is the way it is that when we received the code from Berkeley, it was originally written by university students. The joke was that it was the dumping ground for everyone's PhD thesis. So effectively, what the license says is you're not allowed to sue the regents of the University of California because they would be liable for this code, and they obviously have released it in open source. And because it's that is the license we received it with, we can't change it. That's what we have. We can add to it. We could add additional things, but that's what we received. So that's why it's there.
Now, do we still see Postgres being used for people's PhD thesis? So I want to talk about this is an interesting question. Like, how much have you seen Postgres, still being used for research in academia?
Well, the only one I learned of because I ran into them at PyCon last year was I think someone's gonna have to fact check me, a PhD dissertation out of Carnegie Mellon to automatically tune Postgres and I think other databases for whatever is actually running on the system.
But actually, I know that Postgres does have a rich history of accepting contributions from academia. A lot of the work on full text search, some of the indexing work, and these are now being deployed widely in commercial systems. So, there is this rich, academic history, still that you see in Postgres today. Other questions?
So, given that all you guys have been involved in Postgres for a second or two, when you started working on it, hardware was in a very different place, and the challenges of computing and building a database were very different than they are now. How do you find that Postgres has changed and the challenges of working with Postgres have changed given the difference in the challenges the overall software industry has faced and moved with over time?
Thank you. Excellent question. Who wants first crack at that? Robert.
So it's not actually different. Storage sucked back then, storage sucks now. It may be slightly different in the ways that it sucks, but mostly it's the same. So you used to have, like I know when I got excited about like big systems, right, and like storage arrays, and then you'd have latency between your storage array and your actual system, and now you move it into the cloud, where like it's all over networks, and you have latency between your storage systems and your database, and it's kind of hidden from you to actually see what's going on. So I think that's probably the difference, depending on your deployment model, is that observability has somehow gotten worse, even though we didn't have good observability back then. But it's definitely gotten worse in that sense. But otherwise, like you're still dealing with the same things. Like it's CPU, it's memory, and it's storage. And at the end of the day, like those are your bottlenecks, and it's all figuring out, why is the computer doing something different than what I wish it would do? And then how do I convince it to do what I want it to do? So.
So I'd like to add to that one of the biggest differences now is that storage used to suck and it doesn't suck anymore. But that implies that you're not deploying to the cloud. But the fact is that like the NVMe SSD drives that we have today, if we deploy directly on servers, have just changed completely the pattern. Like almost everything we did for tuning no longer applies, right? Because it's I don't know, millions of times faster than it used to be. Like that's a lot. And you say, yeah, we still have storage and memory, and we never have we still have CPU and memory. We never have enough of it. But one big difference there as well is we have a lot more CPUs now. Like, yes, they are faster. They are in fact a lot faster, but the number of them has increased more than the speed of the individual ones. So things like back then, it was not as big a problem to not have parallel query. If we didn't have parallel query today, it would be a very big problem. And I think the final thing to add that we're looking at much more now than we did now is distributed systems. Like wherever we are, we no longer just have a Postgres. And we don't just have a master standby setup or anything. Like we have lots of nodes in lots of places, and that has created a whole new set of challenges that we didn't have before.
Not totally related to this, but one of the problems that we have is as a person who's building the pre-built packages for Postgres, I don't think we can utilize the CPUs that much. So we have to find a way to be able to fully utilize the hardware. But this is another story.
Actually, that actually leads me to a question. So how do you think we can better utilize the hardware? Do you have like some things in mind where we can continue to improve Postgres in that way?
I'm not a hacker, first of all. I'm just a poor packager. So one of the things that I was told several times was to be able to compile Postgres for each specific CPU architecture with specific instructions, which we cannot do right now. We can, but it's going to require billions of work, lines of work, whatever. So I don't know. I mean, currently we are building with the minimal set of compatibility stuff. I'm sure in the next 10 years we have to change something else.
Devrim, please come to my presentation tomorrow. Thank you.
I heard a rumor this might change in Postgres 16. Go to the talk tomorrow morning. All right. Questions? Yeah.
Hello. My question is regarding, and you sort of mentioned distributed systems. My question is regarding where do you see Postgres role nowadays, where we have clusters, either sharded clusters or shared nothing clusters. I know that many projects that are distributed databases use Postgres either in the background or as a fork. And where do you see the project itself, the role where a node versus a whole distributed system?
All right. Who wants to go first? Take Bruce.
I mean, going back to the previous question, Postgres is a very simple system. We haven't really chased after a lot of sort of the up and coming things like threading or different storage optimizations. And because of that, as the underlying hardware changed, we could kind of adapt to it real easily. When cloud came, we didn't have to do much at all. Postgres was ready for that because we had written it in a very abstract way that didn't really rely on a lot of the operating system features. And the same thing with when SSDs came, we really just needed to change random page cost, allow it to be table space specific. As storage is getting bigger, I've been on sharding for 5 years now, and the way we did it is instead of sort of ripping everything out and redoing it, we ended up enhancing the parallelism, the partitioning, and the foreign data wrappers to allow for that sharding to be implemented. So I would say we're waiting for people to catch up to that need. I'd say we've sort of built it, but we don't have a lot of people who need it because right now most workloads are handled on a single server. I don't have a lot of people. I think we should be ready for high write volume, high data volume workloads, but we haven't really gotten the push yet, I would say, in terms of adoption, or people are using other things for that. And then with distributed, that's obviously like a Yugabyte case, I guess you're alluding to, or something that's been redesigned Postgres for that kind of use case. And it's going to be interesting to know whether that's something we're going to need to address, or it's a limited use case that's going to be specialized, right? We're pretty much a general purpose database, and we're always trying to figure out what's general purpose tomorrow. Well, JSON is general purpose now, right? And we saw that from the popularity of Mongo, for example. So we're always looking to see where the industry's going, what things are popular, and what things are where we're going to be able to take Postgres in a way that is seamless and does not sort of disrupt its general value. And I think we've succeeded with that with sharding, and I think we need to look at see is distributed the next angle, is what is the next angle? We're not even sure.
Yeah, I think one of the things that is always going on within the community is because we have such a liberal license, right? And people can take Postgres and do all kinds of experimentation with it. There's a temptation to want to like follow those paths and put all that stuff in core and like, wouldn't this be so awesome? But in a lot of cases, we've seen like forks will happen and then they die out, because usually what you end up doing is like people make trade-offs for a specific use case, right? And you can always optimize for those use cases in a way that'll be more performant than the general platform that Postgres provides. But if that makes it non-optimal or unusable for other cases, right, that's where the problem lies. So I think what we really have often looked for is we need to see like 2 or 3 different but very successful cases, that build on the same sort of piece of technology. And when we see that, then we know like, okay, what are the parts that we could pull into the core to enable those to make their lives easier. Even if you look at like distributed, I mean, there's so many different versions of that with Postgres, whether it's like foreign data wrappers or it's Citus or, you mentioned Yugabyte. Like, so there are a lot of different ways people are going after that problem. And, there's more to come. There was one announced like yesterday or whatever, right? Like the PG Edge guys. So I think in those cases, like we know that stuff's going to get pushed forward. So people are looking at that. The good thing I think now that has really changed is Postgres itself has gotten large enough that people are first looking at Postgres as the basis for like, let me go start my experiments on that, whether it's university or it's commercial or what have you. People understand like, take parts of Postgres, start with that as your base, and then go optimize for the use case you want to go try to, prove in the market. So that's really nice because it allows it, for us to more easily see these things and see where they're useful and valuable as an overall project. So that I think is a big thing that will shape us going forward, that because people start with Postgres, it should be easier to consume those in as those things actually win in the market. But it certainly takes, it can be 5-10 years in some cases for those to actually play out and see like, oh yeah, this is definitely a thing we need to add and here's how we should add it.
So actually, that leads me to a question about a more recent innovation in Postgres. I think it was Postgres 13 called table access methods. So for those of you who are not familiar, table access methods is the Postgres way of saying pluggable storage. And we have table access methods and index access methods for defining your own table, your own storage strategy and indexing strategy. So, I think we're still, it's still early on in this, but I think, over the past couple of years, we've seen more Postgres extensions being built with their own storage system, their own indexing system. How do you see this impacting in terms of what people are doing around forking Postgres or experimenting with their own types of storage, and what do you see for the project in that way?
Well, I think first of all, Postgres has always been, like all the way back to the Berkeley days, about extensibility, right? About being able to extend things. Actually, up until recently, storage was one of the few things that was not pluggable in Postgres, right? And that, for one thing, that brings a lot of value to the people who are building these extensions, right? Doing these experiments because they don't have to write the whole database to do it, and they can work it off the fork. And as a project, what we get is we get other people doing things, right? We get like you get a distributed workload of the developers as well, and people can run a lot of experiments, and in particular, all the experiments that fail. As we know, most of our experiments fail. I'm sure anyone who's ever done anything know that, right? And they fail, and they will have no lasting cost on the Postgres code base from failing, right? Because that code never made it in. And the ones that are really successful can eventually get absorbed into the Postgres core, and some of them will look very different once they do, but the extension mechanism can be a great way to prove that it can be done and sort of the broad strokes of it, but then when you bring it into the core, you might want to build it in a completely different way. But also just the fact that we don't have, I mean, we do still, I'm sure, have a fair amount of failed experiments that are still costing us as technical debt in the Postgres code, but having these clear extension points makes less of that because we can fail externally.
And you bring up a good point about extensions. You know, I like to describe them as a way to add functionality to Postgres without having to fork Postgres. So actually, you know, on that note, what's one of your favorite extensions and why?
So if there's one extension that we absolutely should put into core, no doubt about it in my mind, is an extension called PG Hint Plan, which allows you to write query hints so that you can actually see what the hell your database is doing and understand why it's making the choices it's making. Anybody else want to champion PG Hint Plan on the panel? Yeah, I think we have RPMs for that, right? Yes, yeah, see, because people need it. People want it. I don't know why it hasn't happened yet. The code is there, dude. It can be run. Even some of the cloud systems have it.
I think if you want something in core, that would be PG statements, which is not in core, but in core, or somewhere between the core and not core. So, but on the other hand, I was about to check the list of the stuff that I've been packaging. Like the number of extensions that Postgres has is like great. Remember, like 10 years ago, I made a poll about your favorite extensions, and the answers I got was awesome. Like PG Partman, we should have partitioning. That partitioning. No, I'm not talking about the code, but I'm talking about the functionality in Postgres. That would be awesome. And PostGIS, for a very good reason, and PG routing. And there are lots of stuff that makes Postgres easier to use, and I would like to see them in core. And I would love to see Postgres a connection pooler in core, but there's something else. Sorry.
We're hitting all the hot button issues today. Mark, what, you know, for your many years of running databases, what have been your favorite extensions to use? They don't necessarily need to be in core. Just, you know, what are your favorite extensions?
Well, from my benchmarking days, one thing I always wanted was to be able to get the operating system stats out of Postgres as an extension. So I wrote one. So I called it PG Proc Tab. I kind of don't remember. Oh, process table. Yeah. So I wrote one to grab all the system statistics out of Linux, and you could query all of them and look at all of that raw fun.
Cool. All right. Questions? Yep, in the back. Make me exercise today.
Yeah, I just wanted to know, I guess you guys do know that announcement by Amazon using PostgreSQL as infrastructure as a SQL platform. Is that something that, how did that come about? Oh, well, hopefully it went to Postgres then. You know, I just wondered if the community was part of that, or they just sort of took and ran with it.
Wait, are we talking? Is this the TLE? Trusted Language Extensions? Yep. So can you clarify the project, please? Well, can you clarify the project? I think we're trying to figure out which. Oh, okay. Oh, so the serverless project. Okay, yeah. Okay, I can speak briefly to that. Sorry, so I'll just while walking to the front. So yeah, so I think that's an Amazon specific project. Is the long story short. Yeah. So yeah, I'll say disclosure. I do work at Amazon. So Amazon, we do employ a bunch of contributors that work on Postgres, in various different ways. There are people who are committing to the project, people contributing. But you see this throughout all the different companies in the Postgres ecosystem, and we collaborate on the mailing list, much as other people from other companies are collaborating. Right. Questions? Yeah. Yes. Okay, I like
So I have a question. We've already kind of mentioned a little bit about pluggable storage or table access methods. Obviously, there are a lot of kinds of things we could do with that, like columnar storage and index-oriented storage and stuff like that. How long do you think it will take for the APIs to become a lot less heap-centric to make it easier to develop very different storage approaches than we have now?
Thank you. All right. Who wants that?
Yeah, what Robert said. The short answer to that question is a long time. It'll evolve eventually, but we haven't seen that much finished projects on the table access method APIs. There are a lot of people started and very few people finished kind of things. So yeah, it is very centric to the implementation that we have today, and I think we're just going to have to see the actual requirements that come out of people actually building the other things. Like there is columnar store, right? The Citus columnar store now actually uses the table access method APIs. But there aren't that many other things that are production ready that are using this API. So I think as we see more of those coming out, we'll be adjusting the APIs or adding to the APIs to cover for it. But these are very complicated things to build, so yeah, it will take a lot of time.
Questions?
So the author of SQLite, they look at Postgres as a guidance to implement their features. I wonder what who Postgres look at to implement features. So I'm curious.
So I think the simplest answer to that is, at this point, it's mostly towards the SQL standard. Back in the day, it might have been a little bit more, what do the other databases have as features, and how easy is that to re-implement in Postgres? But now, at this point, like we have so many features, I guess, at this point, like we've covered all the bases, that it's really about, if you're going to add something new as a feature set, like what can you add that is already a standard someplace, and then kind of stay with that standards-based implementation. So I mean, like the big one, I think merge, had been worked on for, I don't know, 5 years at least, and maybe 10, 12. Okay, yeah, so long time, at least one pandemic ago. So that was one where, like, okay, it was in the standard, it's been implemented in multiple databases, we know we want it, it's just a matter of getting it in, and it's hard. But I think that's primarily from when I think of, like, from a direct user standpoint, that's the thing that I think we look at from, like, a language standpoint, SQL standpoint. We mostly look towards the standard, what is in there, and how is that implemented, in some of the other big databases. Beyond that, it really that's where it goes off the rails of like, somebody has some niche they want to scratch and they want to, do serverless or do, whatever. And so then those things, it's just a matter of like, see what's winning in the market and what people are after. So even I think like JSON was probably another big one. We had all the underpinnings to do JSON more or less because we had other data types that were similar to it. And I think because it had, an existence in the SQL standard, then we have something to build on and build towards that is easy enough to get consensus around. Because I guess that's the other sort of tricky part is getting, the Postgres community is definitely not a monolithic beast. So getting the community to actually agree on a thing that should be implemented and how it should be implemented, that is tricky enough in itself. So that's one way, like the standard helps us cut through that. That like, yes, it might be dumb the way that it's implemented in the standard, but like it's still the standard, so you probably ought to do it that way.
Is there something that is currently in the standard that is not in Postgres that you would like to see today?
Match recognize.
And what does match recognize do? Cool. Anything else? Any? So match. So there we go. So match recognizing. All right. Any other questions?
How do you see Rust or similar languages affecting Postgres core or extensions that are going into Postgres?
Question on Rust.
At this point, not at all. As in, there are people who built the framework so that you can build Postgres extensions in Rust. I don't think I've seen any Postgres extensions other than, demo extensions so far that are actually, or do we have any live ones that are that people actually use?
I don't think they're used widely in like what we would consider core Postgres community, but in those communities that use them, they're pretty necessary.
Okay, sorry? Oh, okay, yeah. So PostgreSQL, yeah, I've not come across it. But I'll say, whereas, of course, Rust applications being Postgres clients is getting more and more common all the time. I haven't seen any effort of anyone to really do any part of like Postgres core, like rewrite anything in Rust there. I don't think anyone's looking at doing that.
So a couple quick examples for folks that might be interested. The Rust framework, I think it's called PGX, which is a little bit of an unfortunate name, but is the Rust framework for building Postgres extensions and I think function languages as well in Rust that will run in regular Postgres. There's a project called ZomboDB, which uses that framework, and it incorporates, I think, Elasticsearch or Open Elastic or whatever that thing is now. Incorporates that into Postgres to give you like ACID compliant full text search that runs off of that implementation. Also the storage engine for Zenith, which is not called Zenith anymore. What's that called? Neon, thank you. The storage backend for Neon is written primarily in Rust. Yeah.
Like the Postgres side of it
is in C.
And it talks to another thing that's in Rust.
That's in, yeah. So again, like we see some of this work around the edges of people that are using it. But yeah, I don't suspect we're gonna see anybody like rewriting Postgres in Rust anytime soon or anything like that. Like maybe rewrite PG Bouncer in Rust. That would be interesting.
Yeah, I think I've seen 3 or 4 people suggesting a rewrite to Postgres in Rust, and none of them are actual people who've ever written anything in Postgres. So I don't see that happening.
But if you're looking for a PhD thesis, here's a candidate. Right. Questions? Yeah, patches are welcome. Questions? Yeah.
I guess maybe to expand on the theme of what goes into deciding what belongs in core, or sort of what the decision-making process works around there, and also like piggybacking off of like connection pooling, I think came up, but I'd kind of like to expand that into just general like operational side of things. Like, like I think it's been said before that there's a lot of important functionality that people turn to other tooling for, like for HA, or if you need a connection pooler or backup system, backup and restore system even. Like, is it, I guess, maybe just like an open-ended question about what goes into weighing the trade-offs of whether that's something that should be in core, or whether there are already existing solutions for that. Like, is it a bit of a double-edged sword that like you could, if you need all of those things, you could currently right now, like there are a lot of good projects and options available. Like you could use PG Bouncer, you could use PG Backrest, you could use, I forgot the other one that I was going to point out. Is it a bit of a double-edged sword that there's a lot of existing solutions outside of Postgres itself that you can use right now for, weighing whether some of those things should be in core or not?
How do you get something merged into core Postgres?
I guess I can give you an example. So when I realized that we needed some kind of sharding solution years ago, the way not to do it would have been to bring in an entirely new framework and sort of just add it on top or bolt it on the side. That's guaranteed to fail, because at that point you don't have the density of, you don't have any users really who are needing it. And so how do you go at it? And the way you go at it is to enhance the existing functionality of Postgres so that the sharding kind of just appears once all the pieces are lined up in the right way. And we've seen that with a number of cases where something that doesn't naturally look like it should be part of Postgres, but if the extendability's there or the features can be enhanced in a way that the capability becomes available, that's the best chance of success. When you look at something like connection pooling, the problem there is a lot of people will recommend that the connection pooler be on a different server than the database, and therefore doing it inside of Postgres, although it has advantages in terms of authentication and simplicity configuration, limits the use case of what you're doing. So you end up saying, well, okay, we could do it inside of Postgres, but we'd still need to have an external pooler for cases that need that, for high availability, for example, or load balancing. And then you're like, yeah, so it's really sort of preventing us from whipsawing around to trying to do everything. And somebody, a lot of times I come to these conferences and somebody will chew their ear off about how Postgres has to absolutely have X, and I'll basically at the end say, I have never heard anyone ever ask me for that. I'm not saying it's not useful, but a lot of people and a lot of companies will implement whatever somebody's going to pay for. Whatever, if it makes them sign the check, we're going to add it, right? We don't have any checks, right? So that's why Postgres code and the feature set is much more logically consistent across the product, because it effectively it does everything in what we think of it as best we can, a consistent, predictable manner where every feature works with every other feature and things logically kind of flow from the way they are. And that's, I think, part of our success. And trying, as Robert said, and Magnus, sort of trying to sort of ascertain where the market's going and what things do we think we need to go in that direction. Sometimes I feel like we're geniuses in terms of how we're able to deal with SSDs, in terms of how well we handle the cloud at this point, where when we designed it, we had no idea that these things were coming. So a lot of it is not going after things, is sort of sitting back and saying, SQLite is a fantastic database for embedded, right? Citus is great for columnar, right? PostGIS is great for that. And to some extent, you have you get use cases to come in, you can't meet them, you give people a solution that keeps them with Postgres, but gives them an option to have what they want. And then if these things start growing exponentially, then the community starts to say, okay, now we need to really get serious. And can this be done in a way that maintains the integrity of the product? And sometimes it can't, and we just have to say that's not going to be our that just can't be something we can do. Like doing Postgres, an embedded Postgres would just be so far away from where we are that it would just be almost impossible. So same thing with the Rust idea. Yeah, it sounds interesting, but is that really where we want to go?
So I'll add to it. I fully agree with your comment there saying that like the extensibility level is a double-edged sword. Because I mean, as one example, you brought up backrest and whatever, and like the fact that we for many years didn't actually ship a included tool in Postgres to take actual backups was kind of ridiculous, I'd say. But also, had we shipped one from day one, we would. It's very easy to get into the point of saying we ship something that's good enough, right? And we stop there. Whereas now we had an API, which was a terrible API, but it has been improved. But going there, but you create sort of a competition. It's not a competition in the classical market sense of different companies trying to make money off it, but you get a technical competition where we've seen a generation of different things around backups. And I'm pretty sure that had we shipped something 15 years ago or 20 years ago that was just good enough, I'm not sure we would have had something as good as PG Backrest today, because their bar of entry would have been so much higher if there had been something in core that was just good enough for most people, right? So there is a lot of value in that, but it also creates an opening for confusion, particularly for new users of the project, because they don't know which of all these extensions are actually useful, or particularly for things like backup, like which of these things can I rely on? Backups are kind of important, right? So I think we could certainly do. I think we want to keep the way of having things developed externally. Sometimes we develop them externally and later get them in. Sometimes we just leave them externally. But we can certainly do a better job of guiding our users into which of these things they should actually be using. I think we can certainly spend more time on that today.
I just want to add something to this discussion. Like, before 9.0 was released, we were discussing about not having in-core replication, right? And we were talking about the same thing back then. We believed that the hooks that we provide was good enough for the people to build some software like Sloanian, etc. Then now we have awesome in-core replication in Postgres, and discussion was over. Discussion is now over. So eventually we will have to get something like about the backups. I'm not saying today, or I'm not pointing out that we should have a specific backup solution which starts with PG backrest in core, but we should do something.
Yeah, just I think one other note from my mind, having done so much operational work, one thing to always keep in mind is like, packaging is a bit of an illusion, in the sense that like if you were to put PG backrest in core, right? Like I think most people would probably agree it's a good enough tool and probably certainly better than many that have come and gone. But if you were to put that in core now, then like your release schedule is now tied to the core release schedule, right? Which generally means like quarterly updates. Whereas at the moment they can release whenever they want to release. So they actually have a quicker cadence and they can fix bugs faster when they find them and all that kind of stuff. And from an operator's perspective, like, it's not that there's nothing really to be gained, but from the operator's point of view, there's actually very little, in my mind, to be gained. It's much more on the development side, I think, where you would gain things to have it in core and try to like leverage code and whatnot. But as an operator, like your backup tool is a generally fairly external tool anyways, right, on any system. So, I think like we also do look at those kinds of things that like, what are we really getting if we do bundle it? And in some cases, I think you don't really want it bundled. You just want it simple, right? Like that's the thing that people are really trying to figure out is like, well, how do I make this simple? And that goes back to like whether it's packages or you have a vendor or you throw it in a cloud or whatever. use Kubernetes because that solves everything, whatever it is, right? Like, so some cases, things like poolers could be in there, but if they're not, you get some advantages that way. So there's a lot of trade-offs in those decisions. And at the end of the day, like as users, I think we shouldn't be so tied to this idea of like, well, I'd like to have a single installer that just like spit out every tool I needed. There's negative pieces of that, but somebody will actually sell you that too if that's what you really want, right? And you don't have to know that these actually came from like 20 different websites and in different groups. Like you can pay someone to build you that.
Robert is looking for someone to buy his tool he's developing. So the other takeaway is please take backups of all your databases, please. All right, so I think we have time for one more question. So who wants to bring this home? I know a lot of pressure riding on that. All right, so this is going to be the question that sets the tone for the rest of the conference.
No, actually, I have this is a really open source convention, and I have sort of an open source community question. How come, so nowadays it's really popular for open source projects, young and old, to to be under a foundation, sort of, even Linux, for example. How come the Postgres project haven't done so ever? Thank you.
Who wants this one?
So I'm going to see if I'm going to repeat the question correctly, right? So it's basically a question of, we see these sort of big name foundations out there promoting other open source projects and groups of open source projects. So what's up with Postgres? So the basic answer is, as our dysfunction as a community operates, so that also trickles up into the companies and organizations that we do. What I mean by that is, so all of us, right? Most of us all work for different companies here, or don't work for a company or whatever. And we've often come from different backgrounds into the Postgres community, and we need different things. So there are actually a number of nonprofits that help support Postgres. There is, I don't know whether it's worth getting at all of them, but like there's a US one, there's a European one, there's an international one, there's one that holds trademarks, there's other ones out there. There's 2 in Japan, I think we figured. So there are nonprofits out there and these like foundations that have been built and organized around helping Postgres. I think over the years what we've seen is that commercial companies are able to drive adoption much more than we've been able to do as like some kind of marketing arm of the project. And because we've had such a good relationship with those commercial entities, like we haven't had to worry too much about any one commercial entity like taking over the project or trying to strong arm. We actually stumbled over that as a community way back in the first .com bust with a company called Great Bridge. That not that they were strong arming, but they hired a bunch of people and then they busted, as companies did back then. And I think that like the echoes of that impact on the Postgres community, like we really understood like distributed nature and not having everybody work for the same company is a strength. And like maybe doesn't seem like it, in 2002, but in 2022, like we all are like, oh, absolutely, that was the right move to think about that as you were taking jobs and hiring people and seeing companies when they would come into the community. How do you want to interact with those? And again, because of that, like our foundations, we haven't needed a strong foundation to protect us from, external forces that would cause trouble. And so we have them out there. If you want to participate, so this event is essentially sponsored by the PGUS, the Postgres US Foundation, which is a nonprofit foundation. Like we love to take checks if you want to write some. I say we, and I'm not actually I'm not a member of it, but but I help them out when I can. So, and I think the same is true, wherever you are locally, like there's probably some way you could filter up into a foundation if you want to get involved in the community stuff that way. But other than that, like, we don't need that structure And I think even getting an agreement on a new type of foundation that would be big and splashy would be really difficult at this point, just because of where the community's been in the past.
Great. So we're about at time, but I want to end on a forward-looking note. And Bruce, you had made a comment about looking ahead, like what's coming in Postgres, and I think in the short to midterm we have an idea of some of the features that are in development or coming in 16. So can all of you talk about something that you're very excited for that's going to be coming in Postgres, if not this year, but something that's being built towards?
Oh boy. I guess back to the earlier question from the gentleman, sharding is something I've been on for 5 years now, and I'd like to see more adoption of that. I think we have the tools there to kind of get it working. In fact, I was going to send an email out today to somebody to get a little more details, but I feel like we've built it and they haven't come yet, right? I mean, we've enhanced all the things that would make it necessary to develop a sharding solution, but I haven't seen many people benchmark it, deploy it, test it. It feels like it's kind of there. I do have a talk about Postgres challenges, and that's something that I'm always looking at to see what things could go wrong for our community. So that's something, on an opposite note, I'm always looking for things that could derail us or could, diminish the huge momentum that we have. I'm happy to see that we've come back with a very strong community spirit with events. After the pandemic, you're sort of having to rebuild in a lot of ways and sort of resuscitate a lot of the volunteer organizations that we have. And my travel schedule verifies that, that everything's really good. There's huge demand. Obviously, we have 2 days of 2 tracks here at the event, and this is a microcosm of what we're seeing around the world. I'd like to see Southeast Asia get bootstrapped again in terms of events. Asia's been a little slower to kind of dig out from the pandemic, and I'm sort of looking forward to seeing a lot more growth there. I think our next area of growth, surprisingly, is the Middle East, which is an area that we've really not been very visible in for reasons that are very complicated to explain. But it appears that that market is finally going to open up for us, not only in terms of community work, but in terms of adoption and production deployments as well.
Well, I think from a technical standpoint, I'm excited about seeing us working on, like, this has been, I guess, a continuous project almost since I got started with Postgres, which is make Postgres operations easier. Like, there are things in Postgres that are just way too hard, and they shouldn't be, and we've got people working on it. Now, today, I'd say if you have like a small or a medium-sized Postgres database, you need to do almost nothing, right? Almost everything just works. You just need to install Backpress to get your backups done, and then, like, but other than that, it just works. But when you start getting into larger systems, when you start pushing large amounts of transactions, big systems and things, it starts to get complicated. Like, you start needing very specialized skill sets to handle it. And we've removed a bunch of those things. Like, some of the things we do today on a Postgres system without having to do anything, and you imagine that just 10, 15 years ago, like the amount of manpower you had to invest in just to keep your systems running. Just imagine, the days when you had to manually run vacuum everywhere and figure out when and how, and it shut down your systems and all of those things, and they're all gone, right? So we've moved the point of pain much far ahead. But there are still such things. If you push really hard on your number of transactions, you run up against things where running Postgres is very, very hard. And seeing more work in that area to make those also easier. Same thing for whether it's pushing a single instance very hard, scaling it very far up, or in the questions that we talked about, distributed workloads. Again, what Postgres can do there. We can do a lot of things there today, but you as DBAs or developers or whatever need to do a lot of that work. Right? You need to do a lot of work to set it up. You need to do a lot of work to keep it working. And chipping away at those things and making those things easier, both going up and going sideways in the scalability, I think is going to see a lot of the excitement over the years to come. Other than the simple things like doing cooler things with our SQL queries. There's interesting things coming, I'm sure, but I think those are the parts where I see. Unfortunately, we've also seen challenges recently in non-technical areas where we've been, as someone said, yeah, we don't have foundations, we don't have all of these things, and maybe we've been slightly taken by surprise by some things that have happened where we've had to get involved in things that are entirely non-technical, like on the legal side, to make sure that Postgres stays the open project that it is today, and that in the end we all believe that everyone benefits from. Unfortunately, we see a mounting set of challenges there. It's still not bad, but it might get there, and unfortunately it's a challenge that we're going to have to focus on a bit in the future as well.
I think probably for me the thing that I'm really happy to see is mostly just continued growth of the community, and not in like traditional roles necessarily. So there's so many smart people that don't work with Postgres, and I would like to work with those people, you know. And so when I see them starting to join our community like that, just makes me a happy person. And then also, I think the same is true of seeing more developers, and whether that's, you know, sort of just like regular devs or like dev advocates or whatever, other companies that are like building solutions on Postgres. And I think really maximizing what you can do with Postgres and seeing it like fully implemented. You know, like I think if you've been around a long time, then you always look at like PostGIS and you're like, that's a fantastic extension, and there's a whole community of people around it. And you know, if you're like super into GIS, like it's awesome to see what they were able to build on Postgres. But there's a lot of things you can build on Postgres because it's so extensible, and like to be able to build your own functions and constraints and data types and all that, like what people build on this system, I think is great, and the toolkit is all there. What we haven't had in the past, you know, is I would say a large share of the developer community, you know, that doesn't so much care about the database, they care about what the database allows them to do. And that has been really growing quickly the last few years. And to me, that's the exciting thing to see. You know, running stuff at scale is hard, and you know, I've made a good living off of that. But what I think is more interesting is like when you don't have to worry about scale necessarily, and you can focus on, I'm going to solve an interesting problem with a very sophisticated tool set. Like that makes me happy to see those projects.
What was the question? Oh, yeah, thank you. Yeah, the first thing I'm looking for is tomorrow, because I'm going to learn something in Magnus' talk. And as a person who started using Postgres in 1998, and one of the mailing lists that I first started to check was subscribe was PostgreSQL committers. So so from my point of view, what I'm seeing is I'm still waiting for Postgres 17, which will be released next year, and probably 18 the other year. So what I'm trying to say, every year, lots of people, not me, lots of people are contributing lots of great things, and and then now it's like we had LLVM in 11, and now 10 is deprecated, right? So like now we will have more features, and the next version will be always great. So I'm always looking for the next version, what's available over there. And of course, the first one is Magnus. I'm going to learn tomorrow.
I always enjoy seeing things that help the parallelism in Postgres, and well, see it be able to use the hardware better, even obscure things like how data structures are used so you don't burn up your CPU caches and so forth.
Well, thank you. Well, it's 5:30 somewhere, and that somewhere is here. So please give a round of applause for the panelists. And thank you, of course, for your wonderful questions. And just know that, even though this official AMA is over, this is, please carry forward the questions, while we're at scale. The Postgres community prides itself on being very approachable and accessible. As someone who's been using Postgres not as long as these folks here, but coming to my first Postgres conference and realizing, wow, like I know nothing about databases, but having, this community like help, personally guide me and, learn, that's something we pride ourselves on. So again, thank you for your participation. It's 5:31, so please enjoy the rest of your evening.